story hearing. Okay. Now, have you started periodic table at school? You have your textbook. So it starts with a periodic table. What is period? How much did you read in school? Say a little bit about uphill transition element. How much do you know about anything about history of periodic table has been spoken to you? Triads. And what about Mendeleev? So we'll cover this with a little bit of story, see, okay? Because when you go to next grade, that is, you'll not study this in 10th again. So whichever board you study, whether you go to grade 11, so this will be a little bit of a cultural shock on this chapter in terms of one or two ways the nomenclature is done in Cambridge. If you continue in Cambridge, it's fine. But if you go to, say, CBSE or State Board or ICSE, then there's a little bit of change in nomenclature. So let's understand this chapter properly, okay? So periodic table. Periodic table is nothing but a classification of the elements that are known to us at any point of time. Right now, the elements that we know. The elements are classified how? We have naturally occurring elements as well as artificially synthesized elements. Now you have to go back in time. So when elements started getting discovered, so by say 18th century, there was only something around 31 sort of elements that were known. But by the time we came to say 1863, that's when Mendeleev was recognized for his work. So we'll share many good things today. So by 1863, when Mendeleev was, his periodic table came, 63 elements were known at that time. Right now we say there are 114 or 115, whatever it is. 63 elements were known. Now it is not possible for any normal person to know all the 63 elements. By name is fine. Okay, we just started. By name, we can know all the 63. We are now in which year? 1863. So in 1863, you can know all the 63 elements by name. But how do you know what is the property of that element? What is the atomic mass? So there was a reason that you should first, let us try to group elements. That is everyone we do. Like if you have a kitchen today, and if I go to your kitchen and I start making tea, the first question I'll ask you is, chini kahan pe hai? Where is the sugar? So you'll say, look at that, that bottle has sugar. In 99% houses, the tea leaves bottle will also be near the sugar bottle. Do you expect or not? Yes. You won't get cumin or say coriander powder, jeera dhania powder, chini ke saath nahi milega. Again, if you find cumin, that is jeera, and if I ask you where is dhania, coriander, you'll say the next one. The lal mirch, that's how the Indian condiments. So that's a way in a pattern in which we put things together. So all this story starts with, now, you may excuse me for making this comment, but the book that you follow is basically to the British curriculum. There's a lot of geopolitical thing, the way these books are written. This book is written in such a manner, in this chapter typically, it does not want to recognize anyone's good deed that have been done in the world before for periodic table. Specifically, I reserve my comment here. Let me explain 2-3 things and then let's see what is your opinion about that. Let's have a discussion. Like many people have not got at all. Like your book will say a lot of ladies did not get any recognition. But before these ladies and these periodic table, there are a lot of stories. So I actually today grouped all of them together. So this is the first attempt to group things. Okay, we'll have it as a story, you know that. So there was this scientist, Dobrynin. He started making triads. Triads are a group of 3 elements. Now this is not in your course, but you should know this, then only you will get the pleasure. He used to call them like the alkali triad, okay? Then he used to have the halogen triad. Then this used to be the lighter metal triads. So in triads, what is to be seen, if you group them in this manner, you get 3 elements which have the same properties, almost similar properties. We don't say same, we say similar. Now mark this word similar, and if I forget, you ask me again, I have to tell you more about similar. Similar in chemistry has got a lot of meaning. So if you add the atomic masses of the first and third, by geometric mean or mean, you just get the atomic mass of the third one. These were known as triads. Now when people say what are the drawbacks of Dobrynin's model, I personally don't like to hear the word drawback, but itna karna hi bahut hai. Somebody out of those elements trying to find out these sort of relations is great. So we say what could not be better done. So some of the triads later, he could not group all the known elements at that time in the form of these triads. But let's look at the positive outcome. The first positive outcome that he gave was that he was the first person to group elements on the basis of atomic mass. Means if you have atomic mass as a property, it can be used. Like today, how do you group your condiments in your kitchen? Breakfast type items, beverage or breweries type of item. Then cooking. Obviously, you won't get your, insecticide and pesticides won't be out there. They're at the utility section. So on the basis of atomic mass, he was the first person to group. And that group word, that we can group elements, that thought process was first developed by Dobrynin. Did not become very successful because all known elements at that time could not be grouped in this manner. There were three more elements here itself, like fluorine and others, which is not shown here. Those elements had similar properties, but if you add the atomic mass of 1 and 3, you don't get the second one. Aapko samajh mein aa raha hai? But this is the first attempt of somebody to at least group the elements known at that time. This is called the Dobrynin triad. Your book doesn't speak about it, but you should know, because wherever you go in next class, आपका periodic table यहीं से शुरू होगा. In fact, यहाँ से शुरू होना चाहिए. But I'll reserve that comment why these British books are written in such a manner as if every good thing in the world has been done by Britain and US. Throughout the world, other people have not done anything. Again, so you should get out of that syndrome. The next one. The next one is called the Newland's law of octave. Has this been explained properly to you? Newland was a person interested in music, and he first tried to mix music. So what he did, he found out what is the difference between his periodic table and Dobrynin's triads. Was that discussed with you in school? Like, what is the striking difference? Dobrynin brought the word group and atomic mass. That's all. What Newland did, Newland had arranged all the notes of the octave. In octave, what happens? The 8th note is similar to the first note. Do, re, mi, fa, sol, la, ti. Again, do, or yudhi, sa, re, ga, ma, pa, da, ni, then sa. So he found that if he is arranging the elements in such a manner, that time inert gases were not known. ये बहुत पुरानी बातें हैं. Inert gases were not known. Hydrogen is not shown here. So the 8th element, here hydrogen is shown. NCERT books will not show hydrogen. The 8th element exactly repeats its property. In fact, in some of the books, you will not see hydrogen. 8th element exactly repeats the element as the first element. And these properties were found all similar. अब कैसा है sir? सोचो तो, how is the thing? It is like we study chemistry on which day? Friday. Again, next Friday, we'll study chemistry. That means 7 days from now, don't ask anyone what is the subject we'll study. 7 elements later, don't ask what is this element's property. It is same as the other elements in the group. This is known as periodicity. Periodicity means when a particular property repeats itself after a particular interval. That fellow showed me only groups. This fellow combined groups along with periodicity. How? Arranging all the known elements in those days in the order of increasing atomic mass. Mass, always remember mass. In the order of increasing atomic mass as per the 8 notes of music. Means 8 note means the 8th note goes and repeats again after the first note. Just see what a coincidence. It's worked. Lacuna. It worked only for the light elements. Later on, when noble gases were discovered, this particular thing exactly got disturbed. Where do you place the noble elements now? Because noble elements are also similar. If noble elements are similar, then you don't have octave, means you don't have, it's not nonave, you can't have another one. And if you put that, the noble elements does not get placed. So Newland's law of octave is the first one which tells you about the word called periodicity. Before that, we had the word of groups and then periodicity. Correct. After this came, which I like the most, is Dmitry Mendelev's approach. And here I'll talk a lot, okay, because this is something which is absolutely not talked in your book, and that's because of the British culture. They just don't want to recognize this, whereas this is spoken in any other book. Dmitry Mendeleev was actually a Russian. Dmitry Mendeleev started to combine groups and periodicity together, and his was the first accepted periodic table in 1863. In those days, we didn't have IUPAC. We had International Congress of International Chemistry Congress, based out in Germany. Now, what he did, he grouped elements on the basis of increasing order of atomic mass, and he did groups. He did groups like RO, R2O2, like similar form of oxides. He started grouping them. Sirf itna hi nahi. Did they tell you about missing elements in your school? The best part was Mendeleev could actually see when Mendeleev did aluminium. He had a it's like, say this element is known. At that time, the next element known is this. If he tries to group them together, means everything in the group has the same property, the properties don't match. What Mendeleev said, this is not working out, but if he shifts it to the next group, the properties match. So he predicted that there are elements out here which will be discovered later. Now, is the story for that shared with you? Do you know this? What the connect of India in this Indian culture with this? No, that's what is not shared. So you should know. Mendeleev actually, in Mendeleev's periodic table naming, you will see a lot of traces of Sanskrit. So Mendeleev said aluminium is known. The element which is not known, he named it as Eka aluminium. Now you think Eka is Latin. Eka is not Latin. Are you familiar with the word called Ekadashi that we observe? Ekadashi means the moon has got 14 days. After Dashami comes Ekadashi. Okay, Ekadashi, Deodashi, Treyodashi, then Chaturdashi. That's after which is either a full moon or you get dark. Eka means after something. Ekadashi, Dash means 10th day. Ekadashi is the 11th day of the moon. So he said Eka aluminium. Eka aluminium will be an element which I don't know today, will be discovered later. And not only that, those elements were discovered. Eka aluminium was known as gallium later on. 3 elements, he said, Eka silicon. Just look at the amount of work this person has done. Eka silicon, and left gaps. And your next slide will give you the best part. See, this is what Mendeleev predicted. For whom? This is, he has predicted for Eka silicon, means germanium. And when germanium, after many years, was discovered, these are the properties of germanium. What a marvel he has done. Now, socho, that element does not exist. Nobody will believe also. If you today say that there will be a planet which will come up and this planet will have a radius of so-and-so, a moon and a night day of so-and-so, period of rotation so-and-so, and the whole world doesn't want to believe you. And after your death, so many years later, that element, that planet gets discovered with exact data. I picked this up just to show you. And then he said Eka aluminium was gallium. Eka aluminium is just the gallium's observed thing. Whatever he predicted and what came out. This person does not have a Nobel Prize in what you call chemistry. This is the geopolitical affair at that time. Comes from Russia. Communist. He was nominated in 1905, 1906, 1907 thrice. Thrice he was nominated. These stories you should know. Thrice he was nominated. And in his lifetime, a lot of chemistry Nobel Prizes had already been given. 7 had been given. He was nominated way later in his stage of life. 1863, he gave this periodic table. And these people, they stayed with his periodic table till 1971 almost. Before the modern periodic table. Modern periodic table is given credited to Henry Moseley, but there are many people who have worked on it. Henry Moseley is actually the idea of modern periodic table, that the modern periodic table should be based on atomic number, not on atomic mass. He did on atomic mass. Okay, another interesting thing. When he was doing it on atomic mass, there was a German guy called Lothar Meyer who was also working on same periodic table. Similar finding. He was putting them in terms of periodic table. Lothar Meyer was graphing everything on graph. And now you will be very, very interested to know. Lothar Meyer said that whenever he did atomic mass is to atomic volume, he used to plot them and he used to say the graph used to be a zigzag graph, like a wave. And he used to say any 2 points in that graph which are in the same phase will be elements which have same properties. Another periodicity, exactly found correct. But the credit goes to Mendeleev because the publishing of works of Mendeleev was much prior to Lothar Meyer. Now they say in 1907, in the first voting count, Mendeleev got out of 5 votes in the Royal Swedish Academy, who gives you Nobel Prizes, he got 4:1. They re-voted 4:5. So later on, you'll hear about a person, when you study acids, called the Arrhenius concept of acid. Arrhenius was one person in that Royal Swedish Academy board. His theory of ionic dissociation was highly criticized by Mendeleev. उसका बदला वो वहां लिया. But the element 101 in the periodic table is honored in the name of Mendeleev. So it is known as Mendelevium. This was shared? No. 101. Element number 101 is in the name. That's the only accreditation we give to this one. 71 तक इसका periodic table use किए, but you didn't give a Nobel Prize to him. And till date, I don't see anything so much except Henry Becquerel. I don't know whether you know Henry Becquerel. He's the person who discovered radioactivity. Apart from his discovery and this discovery, nothing fascinates me more in chemistry, because a person predicting 3 elements which are not known at that time, and that too leaving the space in his work saying that मुझे नहीं पता, अभी नहीं है, आपने फिर खाली क्यों छोड़ा, क्लासिफाई नहीं, यहाँ रख दो खाली, इधर एक बच्चा आएगा. It's like me starting a batch of students and yet keeping one seat, thinking that in the month of July, one child will come here and he will be from this school, he will be from this thing, this block apartment. Can you? And he is not one, 3 children he has predicted, and bang on prediction, no Nobel Prize. With this, you start the chapter, because if you don't know this part, then there is no pleasure. Your book will only very, very cutthroat British mannerism. They will just start the chapter with Mendeleev's periodic table gave us the idea of groups. Groups didn't come from Mendeleev. Groups came from triads. Periodicity came from Newland. Mendeleev combined both and started making groups of similar properties. And he arranged everything in the order of increasing order of atomic mass. Okay? Now, increasing order of atomic mass karne se, you know what is the problem if you do increasing order of atomic mass? The problem is, let's say you take an element called hydrogen. Hydrogen has got 3 isotopes. Do you know what is an isotope? An isotope is an atom of the same element which bears the same atomic number but different atomic mass. Okay. Before we go to atomic number and atomic mass, let us know whether you are clear on this concept or not. So let's say I have an element, say X. X as an element will always be denoted by Z out here and A out here. The Z stands for the atomic number. This stands for atomic number, which is equal to the number of count of protons. Okay. And A stands for the mass number. But mass number, you will say, sir, this should be relative atomic mass. That I'll come. Actually, this stands for the mass number. And the mass number is the number of nucleons. And these nucleons are nothing but the sum of protons plus neutrons, which actually reside in the nucleus of the atom. Have you got it? Now we come to the isotopes. So let's take the example of hydrogen. Hydrogen has got H11, H12, and H13. What does it mean? Isotopes are atoms of the element. All the 3 are element. Same element, hydrogen, but different atoms. Isotopes are atoms of the element, same element, which have the same atomic number, but differ in their mass number. Now, that means if I look at here, what should be the count of proton? 1 proton. And here, this is the summation of what? This is the summation of proton plus neutron. If the sum is 1 and I know there is 1 proton, that means neutron should be 0 out here. Is this clear? Out here, it is same, 1 proton. So here it should be 1 plus 1. And it should be 1 proton, it should be 1 plus 2. Trivial names are prosium, deuterium, tritium. Dihydrogen oxide, H2O, is known as water. Deuterium oxide is known as heavy water, used in nuclear reactors. This is also available, heavy water plants, okay? They reduce the speed. Now the question is, if you are actually arranging a periodic table in the order of atomic mass, which our friend Dmitry Mendeleev was doing, then are the masses of these 2 same? No, they are not same. The mass numbers are different. Then why are you showing hydrogen at only one place? Your periodic table should have prosium at one place, deuterium at one place, tritium at one place. Similarly, we'll get another element later on, which is known as chlorine, C1735, and then C1737. You get it in two variants. But he showed only chlorine. So the objection is, if it is, these are the drawbacks of Mendeleev's periodic table. Position of isotopes is not clear. If you are arranging the periodic table in the increasing order of atomic masses, then this should find a place, this should find a place. Now, since you have studied a little bit about it in school, now since the modern periodic table is based on what? Atomic number. The modern periodic table is based on atomic number. So if you look at atomic number, in all these three, if you see the atomic number, it's same. If you see the atomic number out here, it's same. And my periodic table is based on atomic number. I need not give 2 places for chlorine. I need not give 3 places for hydrogen, because I am classifying elements on the basis of their atomic number, not atomic mass. Is this concept getting clear? Mendeleev arranged it in atomic mass. अगर आपने mass पे किया है, तो that's your unique property. This has different mass, this has different mass, this has different mass. So why don't you show them at 3 places? Modern periodic table is not on mass number. Modern periodic table is on atomic number. But in all these three, the atomic number is same. And if the atomic number is same, then the story is very simple. You need not keep 3 different places for them. Is this getting clear? In your book, you will see that this has been written as the relative atomic mass. So as I told you, that the mass number is always the relative atomic mass. So if we take oxygen, okay, if we take oxygen is 816. So if somebody tells me what is the mass number, I'll say the mass number is 8. What is the count of protons? I will say the mass number is 16. What is the count of protons? I'll say the count of protons is 8. That means the count of neutrons is also equal to 8. Understood? Somebody tells me, what is the relative atomic mass of oxygen? What is the relative atomic mass of oxygen? I'll say 16U. But when you see the periodic table, you will see that oxygen's atomic mass will be in some decimal. Every atom is having its relative atomic mass in decimal. Let's say if you look at the periodic table, you will see chlorine as C1735.5. Now this is again a reason of worry. 35.5 means, sir, you said ऊपर में mass number होता है. Very good. Mass number is proton plus neutron. Point means, did somebody bite a proton or did somebody bite a neutron? No, it's not like that. This is called weighted average. Not average directly, weighted average. Weighted average means, see, the way you calculate your marks average, you think the importance of English, second language, maths, physics, all is same. So you add up everything and you divide by the number of subjects. Weighted average means you give weightage to each. Like say, suppose if I'm making an ice cream, or say in which one condiment is costly, so the cost part for that, if that condiment is present more, the cost of the ice cream automatically goes up. Are you getting it? This one in the atmosphere is found in, if you take a sample of chlorine, we get 25% of this and you get 75% of this. Anytime if we sample chlorine in the atmosphere, we'll get molecules. We'll get atoms of chlorine. The chlorine atoms will generally be 75% of this and this. So how do you arrive at this number? We arrive at this number by taking 0.75 portion of 35 and we add it with 0.25 portion of how much? 37. Did you get it? This is how the 100% sampling is done. So this will give me how much? 35.5. So typically whenever you see the periodic table, and in your book it will be written as relative atomic mass, so it will be always in decimals. That is correct. It does not represent the oxygen atom. It represents the weighted average of all types of oxygen atoms that we get in the universe. In universe we get 1 or 2, everything has isotope, like carbon. Carbon has got carbon 12, carbon 14, carbon 11. So the weighted average is shown. Take clear hua hai? So let's go to the modern periodic table. Now in modern periodic table also you will have a small cultural issue. Though you have studied this, has been started in your school. So I'll first tell you what is the cultural issue. The position of hydrogen is never clear. Okay, hydrogen is always shown separately in all good periodic tables. You may get many other periodic tables also where hydrogen will be shown here. Hydrogen will be shown here, right here. And lithium will come one step down. Hydrogen takes this position and lithium, like if I see this periodic table, hydrogen is right here. Hydrogen is here, not lithium, hydrogen stays here itself. So they will put hydrogen here. This is one cultural shock you may get. But if you ask me, position, this is correct. Position of hydrogen. In good periodic tables, hydrogen will be shown separate. Then comes naming. Before I tell you what is group and all, in your Cambridge, it is named as group 1, group 2. And after that, they start from here as 3, 4, 5, 6, 7, 8. If you go and study whether in CBSE or any other places, your naming will not be like this. Your naming will be rather many international books also. I don't know why Cambridge sticks to this. This will be group 1. This will be group 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This becomes 13. What is group 3 here becomes 13. And like if you ask your CBSE counterparts, hey, tell me what is the group number of inert gases, they will immediately say group 18. You will say group 8. ये पुराना technology है. In all books that you refer, so in higher grades when you go, don't get confused. But this year we have to stick to the way it has been shown to us. So how is this periodic table studied? Before we get into the chapter, this periodic table will study 2 groups, then a block which is known as the transition elements, and thereafter 3, 4, 5, 6, 7, 8. That 3 starts from boron. But the way I have learned it is 1, 2, 3, 4, 5, 6. For me, boron starts from 13. Boron, aluminum, and all those start from 13. Is this clear? Chali. आते हैं अभी periodic table में. So, I may go by the book or may not go by the book. Initially, let me first puke down whatever I know. So the first thing you should know, what is the periodic function? Periodic function means on what basis is this periodic table arranged, right? The increasing trend of atomic numbers is the periodic function for the modern periodic table. Mendeleev's periodic table's periodic function was atomic mass. So here the periodic function is the increasing trend of atomic numbers. So the periodic property said that properties of elements are the periodic functions of their atomic number. Properties of elements, and what properties? Chemical and physical. Chemical and physical properties of elements are the periodic function of their atomic numbers. Whereas Mendeleev के लिए क्या था? Properties of elements are the periodic function. Periodic function means after a particular period, that property is again going to repeat. After a particular period, that property will again repeat. Then I had told you that there is a word called similar. Similar as a word in chemistry. Whenever you say similar chemical and physical, so similar means it can be that some properties are same and some properties will show a gradual trend. That trend can be either going up or going down. Let me give you an example. Right now we are at apartment 1303. If we go to apartment 1403, we say it is similar. Few things will be same. What is this few things? The square feet of my apartment and 1403 will be same. However, the altitude of my apartment and that apartment gets a slight gradual increase. If I go to apartment 1203, few properties will remain same. So when we understand, when we go with this word similar, like say for example, sodium and potassium, when we will study this in detail, don't worry. Sodium and potassium have their valency as 1, but the atomic mass is a slow increase. If the atomic mass is a slow increase, the boiling point will also be a slow increase. ज़्यादा भारी है ना? Or the density will also be a slowly increase. So similar in chemistry means certain properties which will be same, certain will show a gradual increase, and that gradual increase may be either a plus or a minus. Understood? Okay. The periodic table consists of two types of arrangement. One is called the horizontal grouping, which is known as, not the horizontal grouping, I should not use the word grouping, the horizontal layers, which is known as periods. There are 7 periods in the modern periodic table. In higher grades, you will understand that these 7 periods correspond to the principal quantum number. Now it will sound to you as Greek and Latin, n equal to 1, n equal to 2, they will write. So this is the period. We have 7 periods, and we have how many? If you go by CBSE, we have got 18 groups. If you go by here, we have got 8 groups and a block of transition elements. You know, these transition elements earlier was one as 2A, 2B, 3A, 3B, 3A, 3C, like that. That's why this is a confusing way. We always say it has got 18 groups, but in your book it is shown as 8 groups, right? There are 2 more layers known as lanthanides and actinides. When you study about block elements, you will study that these are S block elements, these are P block elements, then these are D block elements. These are the orbitals which you will study in higher grades, SPDF. This is F block elements. It starts from lanthanum and ends in deuterium, and again starts from actinium and ends in lawrencium. Few years back, you know, there was a lot of fight used to go between Russians and Americans. Whenever they used to discover an element, they used to name it in their name. Now IUPAC does not allow that. Now IUPAC has got a strict manner in which otherwise these people used to, like, something is found in Tennessee, so, or Tennessee and like that, they will used to name American. There is I don't exactly remember the Russian name, but there is an element which is disputed. Americans call it Americum, Russians don't agree to it. They call it their way. So now IUPAC has made it one go. Okay. For us, the periodic table consists of what? The periodic table consists of periods and groups. Periods are the horizontal layout and groups are the vertical ones. We don't call them as group out here. However, if you see these what you call the periodic table, there will be a sudden mismatch of atomic number. Like, see, 56. After 56, suddenly 72 has come. Let me first explain these things to you. After 56, 72 has come. Barium, and then lanthanum is 57. After 56, 57, lanthanum should come. Ab maza dekho. If you insert lanthanum out here, and thereafter all the series of lanthanides out here, the entire periodic table's group similarity goes for a toss. That means it's not only the atomic number. There are many other stories, and this is like a Pandora's box where truths got revealed later and later. They found that abhi aise sajane se baith nahi raha hai. So you see here you have got how much? 56, so 57. After that, straight away hafnium 72. So 57 to 71 actually should get inside here. But if you insert them here, ye aage chala jayega. So when you go to the quantum mechanical model, you will see that the electron filling also here is happening in the 6th orbital, the F orbital. That's why these are called F block elements. And similarly, bilkul uske niche you will see actinium 89, after that 88, 89, 90 should have been here. No, 104 is here. Rutherfordium. All names were given like that. Okay. So this is studied separately, lanthanides and actinides. So if you ask anyone, can you just quickly explain how the periodic table is? Well, the periodic table is set up in such a way that on the left hand and right hand side, I have the most reactive elements. Reactive metals. These are called the alkali metals. They will always form alkali, group 1. What are alkali? Alkali means their oxides will be basic in nature. And those oxides, those bases, which are water soluble, are known as alkali. So they are known as alkali metals. The second group is known as alkali earth metals. These will also be alkali, not as strong as these, but are found in the crust of the earth. Look at them, magnesium, calcium. Then comes, but they are called metals, right? They are called metals. When you talk about metals and non-metals, some of the properties of metals are what? Metals are malleable, metals are ductile, metals are sonorous. You know what is sonorous? Okay, it makes a sound. Metals are shiny, metals conduct electricity. But look at sodium. Neither sodium is tough, neither sodium is hard, neither sodium is malleable, neither sodium is calcium. Is calcium malleable? If it was malleable, we could have hammered her bones and made them thin sheets of Sahasra's bones. But we can't make it. Is it possible? No. So when the word of metal comes to you, metal means what? Jiska danda leke marne se sar fatega. That is actually these blue ones. These are the dense metals, as you call it. And you will get all hard metals out here. Tungsten milega, aapko yahan pe titanium milega. These are real metals, okay? After the metal goes, then you actually get this group, the group that you see little bit orangish. They're very stylish. They are known as metalloids. In Hindi, I call them thali ka bangan. Na idhar ka, na udhar ka. They will show half metal properties, half non-metal, but not straight. In staggered manner, they are there. Even carbon bhi thoda bahut waisa hi hai. So as we discuss these elements, we will get to know why they are called metalloids. But they are the backbone of the semiconductor industry. The entire electronics is working because of them. And then starts the non-metals. The periodic table has metals and non-metals. There are only two elements which are in liquid state. One belongs to metal, mercury, and one belongs to non-metal, which is bromine. Rest of the whole periodic table is having only solids and gases. After that comes the non-metals, and this group, which is group 7, this is known as the halogen family. Fluorine, chlorine, bromine, iodine. This is the halogen family. And the last ones are known as the good boys of the colony. The inert gases or noble gases, they don't react with anyone. Do you understand? Before proceeding further with this chapter and discussing like what is the trend and all, tell me two things, whether you understand or not. Do you understand the meaning of this word valency? हाँ या ना clear बोलना, नहीं है तो मैं समझाऊंगा. If there's slight bit of doubt, but don't remain quiet. Yes, जब बोलिए तो valency क्या होता है? Lose an electron. Lose, gain, share. Valency is the tendency of an atom to lose, gain, or share. Okay, as we are talking about valency, do you also understand? ये सब जानेंगे तो easy होगा. Electronic configuration. An electronic configuration means at least from atomic number 1 to 20. That starts from hydrogen and ends in calcium. Okay. Do you understand what is electronic configuration? Sure. Anyone who has doubt, tell me right now, because if you don't understand this, later on you'll get up into problem. Because if you understand this, you need not memorize everything in this chapter. Otherwise, you'll memorize, and there is very chances that if you forget it, then you won't be. They will ask you questions. So and so shows a metallic property, however, doesn't show why. All those can be answered only with this electron configuration. Okay. Electronic configuration will tell me how the electrons of an atom are distributed in the orbits, right? So how, although this is very what you call trivial at this stage, we say that the energy levels of the shell are KMNO. Is KMNO okay with you? Do you understand? Okay, very good. And do you understand something called 2n square? Is 2n square known to you? हाँ या ना बोलो ना भाई, नहीं है तो मैं बता दूंगा. नहीं, very good. The 2n square stands for the Bohr's postulate of how electrons are filled in these shells, KMN. However, this model does not work in grade 11 onwards. Your electrons are actually filled as per the quantum mechanical model. But up to 20, this will support. And that is what we read in 9 and 10. Somebody is asking, if this is wrong, why is this thought? This is thought so that then you understand why it is right. So Bohr says KLMN means the value of n for k is 1, m is 2, 3, 4. Have you understood? So the electrons will always fill in the order of the number 2n square. There are some rules. The rules are that the first shell can accommodate only a maximum 2 electrons, max 2 electrons. Okay, and अब ये सब आपके बुक में नहीं हो सकता है, नहीं हो सकता है, लेटर पढ़ोगे, पर जान लो तब आपको इजी होगा पढ़ना. एंड द लास्ट शेल, what is the other name for the last shell? Can anyone tell me? Valence shell. Excellent. It's known as the valence shell. The valence shell can have maximum of only 8 electrons. Agreed? Fine. So if I go by 2n square, then if I see the max count, then 2 into 1 square, which is 2, then 2 into 2 square is 4, which is 8, 2 into 3 square, 9 into 2, 18, and then 4 square, 16 to 32, ऐसा आ रहा है मेरे को. Are you seeing this? 32. These are the maximum capacity of electrons that these shells can hold. But the rule is, if this shell is the last shell, you cannot hold 18. You have to hold how much? Only 8. So the most interesting thing you will see is with, let's show you. Let's say with this atom, say argon, and after argon we have got potassium and calcium. Okay, let's see for these two. So I've got argon with me. Argon's atomic number is 18. 18. So how do you see the electronic configuration? So argon K, L, M. So K can accommodate 2. So 2 electrons accommodated. I've got 10 more electrons with me. Out of these 10 more, my next question comes is 8 electrons. L can accommodate 8. So I have filled up L floor. Now how many more remaining? 8 more remaining. और M में मैंने 8 electrons डाल दिया. M can hold how many? Okay, sorry. मैंने L डाला ही नहीं. अरे, very sorry children. You people also don't see this. K, L, M, N, O. Okay, गलती हो गया. N equal to 2, which means 8. This is 3, and 3 means 18, and this is 4, which means 32. K element. O देखने की जरूरत नहीं है, जरूरत नहीं पड़ेगा. Right. So L can take 8. So L has taken 8. M can take 18. We have filled 8 electrons out here. Understood? Now, the interesting observation starts coming from the next one, which is potassium. Potassium. Potassium is 19. Now, how do you arrange 19 electrons? Now you'll see the difference out here. Potassium, you pull 2 electrons out here, 8 electrons out here. 2 plus 8, how many gone? 10 gone. How many remaining? 9. I enter M shell. M shell can take maximum of how much? 18. So I should fill all the 9 electrons out here. Rule manta hai? No, the rule says if you are the last shell and the last but one shell, you cannot have more than 8 electrons. So in this case, if I put here 9 electrons, then M becomes the last shell. The last shell can have maximum of how much? 8 electrons only. यहाँ पे maximum 8 electrons only. So this does not work. So I have to open the keys of K, L, M, N. यहाँ पे 8 बिठाएंगे और यहाँ पे 1 लाएंगे. ये समझने की कोशिश कीजिए. Is this clear? And then comes calcium. 20, 2, 8, 8, 2. This mode of electron filling works only up till calcium. That's why in the 9th and 10th grade, they don't study more than calcium. That's 1 to 20. But gives you a fair bit of idea how the electronic configuration takes place. Now, if we look at the inert gases because these things are needed for us before we start our chapter. Helium, neon, argon, krypton, xenon, and radon. Okay, this is our inert gases. All our inert gases, one interesting observation we will see, helium has got 2 electrons, so it has got only a single shell, and in its outermost shell we have got 2 electrons. Thereafter, in neon we have 2, 8, argon 2, 8, 8, and all later on you will see that they have all got 8 electrons, 8 electrons, 8 electrons. Have you understood? So 8, 8, 8, 8, 8, 8, and there is one more called 2. And I group this as what? I say that these are the noble gases. What do I mean by noble gases? Unreactive. They are unreactive. If they are unreactive means what? They are stable. And the rule of nature is everyone wants to be stable. And in engineering and science, stability is when your energy is low. How to understand? You go to school by school bus. I make you say that you go and sit on the roof of the bus and go to school. As soon as the bus starts, you will hold the two sides. डर लगना शुरू हो जाता है ना आपको. बच्चे को भी गोद में ले जाके ऐसे चाहो रेलिंग के पास, बच्चा ऐसे बाल पकड़ लेगा आपका, उसको भी डर लगना शुरू हो जाता है. Then what is the safest place in the school bus? Sit on the floor of the school bus. The energy is minimum. Whenever because mgh is the potential energy. Whenever energy is low, you are stable. This is ये आप देसी बोलो नहीं बोलो ऐसे समझोगे आप समझ लो. This is the rat race of every atom. Every atom wants to be stable. The stability means you will not be reactive. And stability, it's like your parents keep on telling you, पढ़ो ना पढ़ो, पढ़ो कुछ बनना है. वो देखो उस बच्चे को, वो देखो. There are some bachas in your colony who have become the benchmark of the geeks. And your parents will always show you example of those. So if you want stability, the atoms keep on saying, कैसे मिलेगा stability? बोलता है इनके जैसा बनो. इनमें ऐसा क्या खास है? इनमें एक चीज खास है. Duplet and octet criteria. If you are a single shell entity, means if you are an atom which is having only a single shell, then please try to become a duplet. Hydrogen. What is the atomic number of hydrogen? 1. How many shells in hydrogen? 1. Single shell entity? Hydrogen is not stable. Hydrogen के लिए colony का अच्छा बच्चा कौन है? Helium. Become a duplet. Therefore, hydrogen can never form ionic compounds. Hydrogen never gives away its electron. यहीं से समझ में आएगा. Because if a hydrogen gives away its electron, उसके atom में है ही क्या? 1 electron and 1 proton. If a hydrogen gives away the electron, it is as good as a proton. The atom itself is lost. Hydrogen will always take 1 electron. So you might say that I have a compound called HCl, which is hydrochloric acid. And we have chlorine which wants 1 electron, and hydrogen has got 1 electron. Hydrogen donates it. No. They share the electron. Hydrogen can never lose the electron. And that is the problem of hydrogen not getting placed by good periodic tables out here, because in group 1, all the atoms will lose 1 electron. We'll come to that story also. बहुत जगह यहाँ ना, as I'm speaking this story with you, there'll be a lot of wires which I leave out. ये connection छोड़ दिया. But maybe not today or someday I will again join that wire. So I told you why hydrogen is a misfit. Hydrogen is somebody who cannot lose the electron. But if you see others in group 1, lithium, so we know all by rhymes. Hydrogen, है लीना की रूबी से friendship और रब से फरियाद, है लीना. Sodium, he. Sodium, potassium, rubidium, cesium, francium, all of them have got a tendency to lose 1 electron, not hydrogen. So hydrogen can't be grouped there. But there are some other properties which make hydrogen group there also. So hydrogen's position is never clear. So coming back to our story, the rat race for every atom is for stability. Stability means they look at these role models. And what is good in these role models is that if you are a double entity, sorry, a single shell, try to get 2 electrons in your outermost orbit, which is called the duplet criteria. Other than that, if you are more than 1 shell, then try to look for octet criteria. So let's take one very interesting element out here. Let's look at the periodic table. It has got hydrogen, and on this side I will have helium, that is atomic number 1, atomic number 2, and I come to lithium, which is atomic number 3. Fine. Lithium's atomic number is 3. So कैसे करें? So let's look at lithium. So छोटा करें, next page में जाते हैं. चलो. Let's look at lithium. Hydrogen 1, then I have got helium on this side, which is 2, and then I come to lithium. What is lithium? Lithium is 3. ये कहानी clear हो जाएगा, your book is clear. Okay, lithium is 3. So let me do the electronic configuration of lithium. I would write that the electronic configuration of lithium is 2 electrons in the first shell and 1 electron in the second shell. How many shells? 2 shells. Lithium. is a two shell entity. This is lithium atom, two shell. So two electrons out here and one electron out here. What does our rule say? If you are more than one shell, look for an octet criteria. That means my fellow is now looking in the market for the deficit of 7 electrons. 7 इलेक्ट्रॉन चाहिए इसको. भाई साहब 7 इलेक्ट्रॉन देने वाला कोई नहीं मिलेगा आपको. Nobody is going to give 7 electrons. So now the criteria comes, sir, how many electrons can we maximum get? The max that you can gain is 3. If you are gaining 3, then somebody is giving you 3. That means the max that you can lose is also 3. And when you go for sharing, then थोड़ा allowance से आपको max count is 4. अब लिथियम का प्रॉब्लम हो गया है, तो क्या मैं कभी अच्छा बच्चा बन ही नहीं सकता हूं? It needs 7 electron, but the maximum the market will sell you is 3 electrons. क्या मैं अच्छा बच्चा बन नहीं सकता हूं? Then somebody crook like me comes and says, तो थोड़ा उल्टा रास्ता सोचना, तू अपना एक बच्चा को मार दे. Kill this child. Very bad in my language, but I'm saying like that. Kill this child. इसको मार देने से you become lithium with one entity, one shell. अब जरा अपने को देखना, तेरे पास है ना 2 electrons हैं. But the moment you killed one positive child, negative child, one positive child became excess for you. Lithium is a neutral atom. This means what? 3 protons. And these are 3 electrons. If there are 3 electrons in the nucleus, I must be having 3 protons. तभी ना जाके ये balance करेगा. Out of 3 electrons, you have killed 1 electron. So now what is the relation? 2 electrons and 3 protons. इसको करेंगे तो 1 plus नहीं आ जाएगा excess. That 1 plus goes here. This is known as lithium ion. And lithium ion has now become an entity which is a single shell entity. And what is the criteria for single shell? Duplet. Is it duplet? Yes, it is duplet. लेकिन ये अनस्टेबल है, शरीर नहीं आत्मा है, भटकेगा अभी, तो इसको शांति देना है. So just look at this side. Let's take an element like you have got helium, neon. Let's say we take argon. Argon is how much? Argon is 18, which means argon is 288. Before argon, we have a lovely thing called chlorine. Chlorine is 17, which means chlorine split is 287. अब जरा chlorine को देखो. Look at chlorine. I am chlorine. I am a 3 shell entity, 287. I also want to be the good boy. And what is my need now? My need is I need 1 electron. एक electron चाहिए. I need 1 electron from the market. कहीं से भी. If that 1 electron comes, my valence shell will occupy how many? 8 electrons. I just become like argon. But at that time, when this 1 electron comes here, 7 plus 1, this becomes 8. Now one negative bachcha has increased. Cl minus. Have you understood? ये भी आत्मा है, भटकेगा. अब ये आत्मा positive, ये negative, strong bond form करेगा. And the compound you will get is lithium chloride, ionic compound. You can yourself predict what will be the formula. In CBSE, I call this as making marriages type. आ जाओ, एक और example देखते हैं. Let's say I have sodium. Sodium is what? Sodium is 11, which means sodium is 281. देखो, lithium, sodium, potassium, all have 1, 1, 1. So group 1, what should be the valency? 1. Group 2, the valency will be 2. In your periodic table, the good way is that you all study boron as group 3. We study it as group number 13. So boron 3 में भी valency आपको 3 मिलेगा. Just below boron कौन है? Aluminium. Aluminium will also be 3. That's why the ion of aluminium will always be Al3 plus. Boron will be B3 plus. So sodium is what? Sodium is forming 281. Now you want to make, so our job in any of these bond formation, these electrons are important. These are known as valence electron, and the rest are known as bound electron. These are bound. मम्मी इनको नहीं छोड़ती है, ये एकदम हमारा BSF आर्मी, right at the border, ready to fight. This is Narsingi police station. ये नहीं जाएगा. So look at chlorine. Chlorine is what? 287. This one. So ये आराम से इसको देगा. So Na becomes Na plus, Cl becomes Cl minus. Compound is NaCl. But Mr. Rajiv Rastogi, if this is magnesium, and if this is chlorine, story becomes different. Magnesium is 12. So magnesium will be 2A2. That means magnesium will lose 2 electrons. क्योंकि नहीं तो magnesium को 6 electron दो. अच्छा बच्चा बनना है तो. Nobody is going to give you 6 electrons. Then again, बच्चा मार दो वाला story. 2 बच्चे बहा दो पानी में. महाभारत में भी है ना. Ganga used to take all her born sons and drown them in water. I don't know whether you know Mahabharata. Raja Shantanu's wife was Ganga, and whenever a child used to be born to it, the clause of Ganga with Raja Shantanu was that you will never utter a word. He was mad, he wanted to marry. He said, I'll marry you, but what I do, you will never say. Whenever a child is born, she just takes it and drowns it. And the day he utters a word, she leaves it. There was a curse. तो बच्चा मारना जैसा, यहाँ भी वैसे ही है. ये 2 बच्चों को बहा दो इसमें. 2 बच्चे बहा देंगे तो ये क्या हो जाएगा? Mg 2 plus. These 2 are gone. These 2 are gone. Now on the other side, the alliance is with chlorine. Chlorine is 287. So it wants to donate 2 electrons. लेकिन ये chlorine क्या बोलता है? अम्मा, I'm full. नाकू एक ही इलेक्ट्रॉन लूंगा, मेरे को तो 2 इलेक्ट्रॉन नहीं चाहिए, 2 लेगा तो फटफट. तो कहता है हमारा ना एक कजिन सिस्टर भी है, उसको भी लेके आओ. 287 और दूसरा इलेक्ट्रॉन इसको दो. So Cl minus, and this becomes Mg. So the product will always be MgCl2. This is how you can predict the type of. Calcium and oxygen. Calcium forms 2 plus, oxygen forms 2 minus. Product is always CaO. But lithium and oxygen, lithium is Li plus, oxygen is O2 minus. 2 lithium लाइए, Li2O, Na2O, K2O. But again you come to group 2, beryllium oxide, BeO, magnesium oxide, MgO, calcium oxide, CaO. So is the story of valency clear? So if you look at the periodic table, now going by your way, say group 1, group 2, and then we have got 3, 4, 5, 6, 7, 8, right? If we take the story of valence electron and valency are completely different things. Valence electron means how many electrons in the last shell. Valency means what will be your tendency to lose, gain or share to become colony ka acha bachcha. Now good story is there. Did you see chlorine out here? Chlorine was 17, and what was argon? Argon was 18. Chlorine tries to become the good boy of his colony. But look at the story of lithium. Lithium ke colony ka jo bachcha hai na, that is actually neon. Lithium is what? Lithium is 3 and neon is 10. Lithium's exact same period, you will get neon. So 7 electrons required, but 7 नहीं मिलेगा. अपना कॉलोनी का अच्छा बच्चा नहीं होगा, but it will become Li2 and will become पिछले कॉलोनी का अच्छा बच्चा बन जाएगा, हीलियम बनेगा. So these side elements will become the good boys of the previous lane, and the non-metals always forms. In fact, if you don't see the periodic table like a calendar, and if you wrap it around like a towel, you see that the inert gases are just the line of control between a +1 and a -1. Try to imagine lithium +1, chlorine -1. Between them, sodium +1, chlorine -1. Between them, argon आके बैठा है. if you just turn the periodic table like this. Okay, so what I was trying to say is valence electron. Okay, now if you see the valence electron of lithium, lithium has got valence electron of 3, chlorine has got a valence electron of okay, ये भी मिटा देते हैं, नहीं तो स्टोरी आपको समझ में नहीं आएगा. Okay, so let's see valence electron count. Your group number, one minute. Your group number will always be equal to your valence electron count. This is one formula. Keep it. If your group number is 1, your valence electron is 1. Valence electron. So if you see chlorine is group number 7. Its valence electron is 7. But if you see the valency, yahan lafda hai. Valency will be like this. These elements can lose 1 electron. This group will lose 2 electron. This group will lose 3 electron. Let's not talk about 4. 5 cannot lose 5 electron. So up till group 3, you will be a very good donor बच्चा. सबको share, सबको देता है. From 5, you become a dacoit. From 5, you will actually gain 3 electrons. From 6, you will gain 2 electron. At 7, you will gain 1 electron. 8 में जाके आपको कुछ भी नहीं चाहिए. So here, what do we say? In these you are lose electron. And these are all about gain electron. That means in 1, 2, and 3, I will always get a tendency of the ions to be +1, +2, +3. These will be the ions. अच्छा बच्चा समझा कि नहीं? +1 की होगा, लूज किया ना. And here I will get the tendency of -3, -2, -1. Which means I will call these elements as, or atoms as, electropositive valency. And these will be known as, this is electropositive, this is also electropositive, and these will be known as electronegative. So whenever an ionic bond is formed, it is formed between an electropositive and an electronegative species. This is electropositive, this is electronegative, right? And if somebody tells me, sir, can you comment on the valency? This is interesting. We don't say the pluses in valency. The valencies will always be 1, 2, 3, and then 3, 2, 1. Sir, why are you so stepmotherly with this group? Well, they share. Excellent. They will share. Because they've got 4 electrons. 4 electron में ना दे पाएगा ना ले पाएगा. इसके लिए और कोई उपाय नहीं है. So they will be gain electrons. समझ में आया? So the question that I once told you, why if I hit with sodium, your head will not break, still it is considered as a metal. Metal's property is electropositive in nature. Just because sodium, calcium forms plus ion, which is cation, they are said as metal. But if you come with the normal mindset of a metal, I want a metallic rod, मारना है किसी को, sodium, potassium उसको support नहीं करता है. Is this clear? And now if you yourself, and if you want some like, sir, एकदम फटाक से कुछ एक example दे दीजिए. So I'm giving from period 3. Period 1 is hydrogen, lithium. I'm going with period 3, sodium. This is magnesium. This will be aluminium. Then यहाँ पे carbon का बाद यहाँ पे आ जाएगा silicon. Okay. And silicon, then this will be 3 means, right, 3 means you can put nitrogen out here. Then out 6 means oxygen is an example, 7 chlorine is an example, here carbon is an example, silicon is an example, nitrogen, then you can think of phosphorus, oxygen means sulfur, they're also same properties. Magnesium के नीचे आएगा calcium, potassium, सब same property. So group 1, now the question arises, what is the valence electron count? 1. What is the valency? 1. Group 2, 2, 2. Group 3, 3, 3. Group 4, 4, 4. Valency is 4. Valency is 4. 4 means 4 share. Group 5, valence electron is 5, valency is again back to 3. What type of valency? Electronegative valency. Group 6, we will have valence electron 6. And in CBSE, how we remember? We say 18 minus group number. This becomes 13. Na? So 18 minus 13 is 5. Like that we do. Next आपके चैप्टर को पढ़ाएंगे. इस पूरे टॉपिक में you should know two things. One is the concept of atomic radius, and then we will target your book study, whether it is there in your book or not. And another is, ये दो पे concept clear कीजिए, whether it is there in your book or not. Atomic radius, NFOA means nuclear force of attraction. Mama is inside the house. Mama is the proton, and all the children are like Pebble City kids, anytime playing outside. What is the control of the mother on all the children? Nuclear force of attraction. Abhi aap socho, just to put a common sense, this is the nucleus, and this is, and we will always talk on the outermost shell because this is war. Army or BSF will go. हमें अंदर के shell से कोई मतलब नहीं है. This shell is known as valence shell. If you have heavy positive charge out here, तो माँ क्या करेगी? कहाँ से पकड़ के रखेगा सबको अंदर? Atomic radius decrease होएगा. लेकिन अगर shells बढ़ते जाएंगे, if the shells go on increasing, then it is like what? The mother is here. Very bad example, huh? The mother is here and this is the child. और हमको ये बच्चे को थप्पड़ मारना है. And suppose lot of shells are here, it is very easy to hit this guy. Mom is in titanium, after that pearl is there, so we hit the child beyond pearl. माँ देख ही नहीं पाई. इसको हम बोलते हैं shielding effect. And if these orbits are not there, then the mother is having a direct eye on the child. अब आप उसको नहीं मार सकते. Then we'll see how do you lose ion forming. एक बच्चा को मार दिया, चला गया, सेकंड बच्चा को नहीं मार पाओगे. Why? एक बच्चा मारने से पहले it was plus n minus n. Now what has happened? One robber gone. Robbers are equal to policemen. One robber in the city has been killed. One policeman has become extra. So the police monitoring on the robbers, per capita robber has increased. Earlier, 11 police used to keep a watch on 11 robbers. One robber died. Now, how many policemen? 11. How many robbers? 10. Don't you think the surveillance will be strong? So, after killing the first electron, you can't take the second electron so easily. So, we say Mg2 plus, पहला वाला electron आराम से जाएगा, दूसरा वाला नहीं जाएगा. This is what we call as ionization potential. Maybe higher class or this class. So next class आपका चैप्टर बहुत सारा रफा दफा हो जाएगा. आप next class we will talk about atomic radius and nuclear force of attraction. If you understand the relation between these two, everything you can answer in periodic table. What happens to the atomic radius this way? What happens to the atomic radius this way? That is what we'll study. रंगारंग कार्यक्रम खत्म हुआ. ठीक है? If I have bored you